Alright, this is lesson 3.1 in variables and patterns. We're going to learn something new about writing equations. We're going to learn how to write an equation, and then we're going to write equations for different patterns. Now, an equation is basically algebra. It is algebra. So we're going to learn about how to write the simplest kind of equations there are. So, to do that, we're going to start with something we know how to do. Complete a table, make a graph from the table. So we have different speeds. So say we're driving in a car. We have the distance at different speeds, driving in a car for up to 6 hours. And we have 50 mile per hour, at 55 mile per hour, and at 60 mile per hour. Table started out for us to give us the idea of what to do. So at 50 mile per hour, we start at 0, and every hour we add 50. 250, 300. Not too bad. If we're at 50 miles per hour, we're counting by 50s. So you can probably assume at 55 miles per hour, we're counting by 55s. A little bit harder, but not too bad. 0, 55, plus 55 is 110, plus 55 is 165, plus 55 is 220, plus 55 is 275, plus 55 is 330. Now at 60 mile per hour, same thing, counting by 60s. 0, 60, 120, 180, 240, 300, and 360. Table, really easy to fill in. Just notice what you're counting by. Now, we're going to make a coordinate graph of all three speeds. First, we're going to steal the title, distance, at different speeds. Our independent variable is time. So time means our distance is our dependent variable. And we have three things to graph, and so we're going to use three different colors. 50 mile per hour is going to be green. 55 mile per hour is going to be blue, and 60 mile per hour is going to be orange. So let's start at 50. Oh, we haven't done our scale yet. I noticed that because as soon as I want to start putting my coordinates, I have nothing to base it on. So now we have to do our scale. Time needs to go from 0 up to 6. So 1, 2, 3, 4, 5, 6. Distance needs to start at 0, and the highest distance we have is 360. I could count by tens, but it's going to take me too long. I can count by hundreds. I'm going to be done too quick. In the middle is 50s. I'm going to count by 50s. .400 is as high as we need to go. Now I can change my colors up and graph the individual speeds. So at 50 miles per hour, we start at 0, 0. And we're counting up by 50s, which is going to be on each corner. Makes that easy for us. And looks like I did an extra one, but that's okay because that's where we know the pattern's going to go. That's a little thick. Let me thin that up so we can still see our points. Now, 55 mile per hour, which is blue, we have 0, 0. 1 is 55, so just a tiny bit higher. 110. 165 is getting a little bit higher than the other one. 220, getting there. 275. 330. So it looks like it's a little bit higher because it is faster. Once again, that was too thick. There you go. Alright, next up is 60 miles per hour, which is going to be orange. So orange is going to be just a little bit higher as well. We start at 0. And then 1 is 60, 2 is 120, 3 is 180, 240, 300, and 360. Connect those. Notice 60 mile per hour is on top because it's the fastest. 50 mile per hour is the slowest. It's on bottom. Let's look at writing some equations. So, writing an equation. This is the general form that all the equations in these units is going to cover. Now, let's talk about what each one of these letters represents. The x is the independent variable. Because it is on the x-axis. The y is the dependent variable. Because it is on the y-axis. Now, the b is the number you start with. So a starting number. And the m is the number that you count with, or a counting number. Alright, now I changed those to a different color to show the difference. Variables are letters, numbers are numbers. So we're going to write an equation for each speed. Notice, the first thing each equation starts with is the dependent variable. If we go back to our graph, the dependent variable is distance. I need to pick a letter that represents distance. D. Each of my equations is going to start with D equals. The starting number is the first number of each pattern when the independent variable is 0. So the number paired with 0. So we have 0, 0, 0. So 0, 0, 0. The counting number is what you're counting up or down by. In the 50 mile per hour, we're counting by 50. 55 mile per hour, we're counting by 55. And 60 mile per hour, we're counting by 60. So, plus 50, plus 55, plus 60. Last but not least, times the independent variable. So my little multiplication dot. The independent variable is time. The letter I'm going to pick is T. So our equations read as this. D equals 0 plus 50 times time. D equals 0 plus 55 times time. And D equals 0 plus 60 times time. The only thing different is the number that was counted by. Everything else was the same. Once you memorize this, writing equations can be very, very easy. Alright, let's jump to our practice problems. Okay, we're given a new equation this time. The equation D equals 70 times time, so pretty much the same thing as we just had, represents the distance in miles traveled after traveling at 70 mile per hour for T hours. So we had 50, 55, 60. Now we have 70 mile per hour. We use this equation to answer questions 1 through 4. Question 1. Complete the table that shows the distance traveled from 0 to 10 hours. If no time has passed, we have traveled 0 miles. In 1 hour, we have traveled 70 because we're traveling 70 miles per hour. And now we're going to count by 70s. So 140, 210, 280, 350, 420, 490, 560. Oops, it's not going to write it for me this time. 560, 630, and 700. Filling in the tables as easy as counting by the counting number. Alright, now we're going to make a coordinate graph from the table. So, stealing the title, distance at 70 mile per hour. Time is our independent variable. Distance is our dependent variable. time goes from 0 to 10, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Distance needs to go up to 700. Now, this is counting by 70s, so I'm going to count by 70s. 70, 140, 210, 280, 350, 420, 490, 560, 630, 700. Time to graph. We only graph in one thing. We don't have to change up the colors. Now, at 0 hours, we're at 0. At 1 hour, we're at 70. We set it up so that all we have to do is worry about hitting the corners, because this is counting by 70s, and so is our table. And there is our graph for D equals 70 times time. Now, using that equation, I'm going to write it right here again. D equals 70 times time. We're going to answer these two questions. First of all, what is the distance when t equals 2.5 hours? The whole point of an equation is that you can plug something in, get something out. We can plug something in, get something out, or plug something in, get something out. In this case, t equals 2.5 hours. We're going to plug it in and get a distance. So, distance equals 70 times 2.5, right where the t belonged. Well, what is 70 times 2.5? Let's do the math. 70 times 2.5. 5 times 0 is 0. 5 times 7 is 35. 2 times 0 is 0. 2 times 7 is 14. Add them all up. Put the decimal one spot over, 175. So D equals 175 miles. We plugged something in, got something out. Number 4, what is the time when D equals 210 miles? This time we're going to plug something in, get something out. 210 equals 70 times what? 70 times what equals 210? Well, let's take a look. Do we see a 210 somewhere up here? Right there. 3 hours. Time equals 3 hours. Alright, let's go back through the worksheet. We're going to learn how to write an equation. We're going to write equations for different patterns. Our first set was a large table, 3 different patterns. Graphed them all in the same graph. Learned how to write an equation, wrote 3 equations. Used an equation to write a table, a graph, and then used the equation to plug numbers in and get numbers out. This is the end of lesson 3.1. Up next is lesson 3.2 in variables and patterns.